Math 3, Unit 4, Section 2, multiplying and dividing rational expressions. Again, we're talking about expressions, which means there isn't an equal sign, and we are just simplifying, okay? Who remembers what to do when you're multiplying with fractions? No. That's with division. So when you're dividing, you change the sign. Okay, yeah, so with fractions here, we just multiply straight across. So tops multiply with tops, bottoms with bottoms, but specifically numerators, denominators. So 2 times 3 is
6.
And 5 times 7 is good. Okay. In general, A times C is
AC.
and B times D would be very good. If we could reduce, we would. Also at this point, if anything on the top could reduce with anything on the bottom, you could reduce prior to multiplying. Okay, so starting with the examples. I always check first to see if I can reduce. Is there any numbers on the top that can reduce with anything on the bottom? No. So we're just going to multiply straight across. 3 times 6 is?
18.
And then what happens with my m's? Okay, so it'll be 5 what?
6.
Good. Okay, now on this next one, so now we're kind of getting to something a little bit more complicated. What are we going to do? We could distribute, but what's easier is leaving them like this and factoring. Yes. And you could do that in whatever order you want. I prefer to factor whatever I can and then start simplifying everything at the same time. So my first fraction, I cannot factor. It's going to stay 3x squared over x plus 2. The second fraction, we're going to have a 12x. And then here on the top, this needs to be factored. Good, and so my multiplication number is 2, and my adding is 3, and I heard someone say 2 and 1. 2 plus 1 makes 3, multiplies to be 2. So, in parentheses, what will I write again? Good, x plus 2 and x plus 1. Now, so if we remember with our binomials, they have to be exactly the same in order to cancel them. So what can I cancel? Good. Anything else? Good. Now these are both monomials, so I can reduce these. Okay, there's nothing adding and subtracting with these, and so they can be reduced. And so 3 cancels, and 3 goes into 12 how many times? Good. And then what about the x's?
There's 1 x.
Good. I can cancel out 1x here with 1 on the top, which makes the top just have 1x. And so my answer is x times x plus 1 over, and what's left on the bottom. Good. And then you can always double check to see if this can factor further, and it can't, so that's my answer. Any questions on that one? Okay, so anything that you have that is not a monomial, you want to always check to see if you can factor it. So this first fraction here, can I do anything on the top?
Yeah.
Good. So we're going to factor out a 2, and we're left with what? Good. Now for the denominator, is there anything I can factor out of the denominator? A 2. And we're left with? Perfect. Times. Now over here, if we just have a single term here, all of this is on the good, and then in the denominator will be a 1. Okay, good. So can we factor this? How will we do it? Good. 6 times 6 is what?
36.
Good. So multiplying is 36 and adding is negative 13. What numbers will work? Good. 9 and 4, and they specifically need to be what? Both of them negatives. Are we okay there? Can I use the shortcut on this? No, why not? We have a coefficient. Good. So we're going to rewrite this out. We get 6x squared minus 9x minus 4x plus 6. And again, because our negative 13x split into negative 9x and negative 4x. Next, we do what? Group them. Okay, my first group, what is the GCF?
3x.
Good, 3x, and we're left with? Good, and the GCF of the second group? Specifically a negative 2, good, because you want that first term to be positive. And so we get a 2x minus 3, because you're dividing by negative 2 to these. And so what does that end up factoring to be? 2x minus 3 and what? And 3x minus 2. So I just decided to write it up here instead of writing it here, bless you, and write it here. Didn't even scare me that time. Okay. Did I lose anybody? We're all good? Okay, what can reduce?
3x from the 2's.
Good, the 2's can reduce. Anything on the top with anything on the bottom, anything else?
2x minus 3.
Good, 2x minus 3. There's nothing left on the bottom now. So I can't reduce anything else. And we're left with x minus 7 and 3x minus 2. Oh, yes, thank you. Sorry. Okay, questions? All right, so now we're going to move on to division. So when you're dividing, a lot of you remember, or I heard some of you, KFC.
He said,
Meaning keep, flip, change. Okay, and so the first one you always keep the same. You flip the second one and you change that from division to multiplication. So this problem would change to 5/4 times 3/1. Can anything reduce here? Nope. So we multiply straight across and we get 15/4. So again, in general, we would keep A over B the same, change to multiplication, flip to D over C, and we'd end up with perfect.
Can you just like cross multiply? Like isn't that the same thing? Or no?
Yes. You would just need to make sure that you keep the correct things on top and the correct things on the bottom. It's easier, I think, to just rewrite it. But, all right. So, again, KFC, yes.
So can we do cross division before we flip the fraction?
You mean reduce before you flip?
Yeah.
No.
No.
So you can only reduce when it's multiplication.
Okay.
Okay? So, again, whenever you get to division, you have to first, KFC, keep the first one the same, change to multiplication, flip the second one. Can I factor out any of my binomials?
Yeah.
So I can't factor anything, but those can cancel, correct? So they're both x plus y's, so we can reduce those and cancel them. Is there anything else? Good. What is my answer? Very good. It is 1/y. Make sure if you have something in the denominator, it stays in the denominator. If there is nothing left on top, there is a 1 on top, because everything's reducing to be 1. Any questions? Okay, now, for some of you, and it depends on how you think things through, But if you want to factor these and then flip them, you could do that, or you could flip them and then factor. I kind of like to do two things at once. So for instance, this one, I know it's going to stay the same. So when I rewrite it over here, I'm going to factor it while I'm rewriting it. So, and we might have to factor it more than once, so just be aware of that. But what would I do first in the top here? Take out a 2, and I'm left with c squared minus 16. Do you notice that that can be factored further? Oh, you mean c minus 4, c plus 4? Okay. So it's kind of up to you and what you want to do. I think I'm going to end up, because this one's factoring further, I kind of want to start over. And so this will be my fully factored form to the right. So we have that first part. Now we have the denominator here. Can that be factored? Okay, and which way do I do that? Good, so we'll do this right underneath it here. So multiplication is 12 and adding is negative 8. So what numbers will multiply to be 12 and add to be negative 8? Negative 6 and negative 2, good. And so again, those will add to be negative 8 and multiply to be a positive 12. And how will I write it over here? Good, c minus 6 and c minus 2. Good. Okay, what do we do next? The division changes to? Good. Okay, and so now we are going to end up flipping these around. Okay, which one do we want to factor first? 4 minus c squared. Does anyone know something that we should do on that? Good, descending order. So negative c squared plus 4. And then what should I do? Very good. Take out a negative 1. So that becomes a positive c squared minus 4. So we always want it in descending order. And then if your first term is a negative, you want to factor out a negative 1. So now this is a difference of squares. And so is it going to go on the top or the bottom over here? The top. And so we're going to write what? Perfect. Any questions there? All right. And then this top one, again, we are multiplying to be 8 and adding to be 6. What numbers will work for that one? Good, 4 and 2. And so how will I write it over here? Good, c plus 4, c plus 2. Do we see anything that can reduce? Okay, a c plus 4. A c plus 2, a c minus 2. Anything else? Nope. And so what will be on top? What will I write? Negative 2, c minus 4 over c minus 6. And so if you need to, you might want to go through and circle anything that's left over so you don't forget something. But because that was that negative, you're going to multiply negative 1 times 2. And those get put together. So any monomials that are left over get multiplied together. And that's your final answer. Do you have any questions? Yes?
So, like, whatever numbers we have left over, like, it's going to be the bottom one.
Yep. So anything that's a monomial, it would just get multiplied together and brought to the front. So even if there was like another C here or whatever, if there was just a letter, all that gets multiplied and put in the front. Any other questions? Okay. So let's move on to this next one. So again, it's a division, so we know we're going to end up having to change things around. Can this factor on the top? So my multiplication is 1 and my adding is -2. What numbers will work? -1, -1. And again, those add to be -2, multiply to be +1. So we have x minus 1, x minus 1 on the top of my first fraction. A squared plus 4. Can I factor that?
A.
Nope. Why not? It's not a difference of squares. Very good. So that is not factorable. What do we do with the division sign? Okay, and then what do we do with this? Flip it. So how will I write it? Oh, and these are supposed to be A's. Sorry. Okay. So what am I going to do now? Cancel out an A minus 1. Notice here, even though both of these are A minus 1s, I can only cancel out 1 for 1. So since I only have one A minus 1 on the bottom, I can only reduce it with one of them on the top. Can anything else reduce? Nope. And so my answer is A minus 1 over A squared plus 4. Any questions? Yes. Well, because it's a 1, we know that 1 times anything doesn't change it. So if you wanted to put this in parentheses and put a 1 in front, you can, but it doesn't change it. Okay. Okay, so this is called a complex fraction. And this is where you have a fraction divided by a fraction. Well, we've already been dealing with complex fractions. They just didn't write it like this at first. All it is taking the A plus B divided by C over D. So it's the same problems. It's just looking different at the beginning.
That looks so weird.
Does that make sense though? So this is just, and we'll write this out kind of the long way right now, but this is r to the 5th over r plus 4 divided by 2r squared over 2r plus 8. So it's just written as a fraction, but it's exactly the same problems as we just have been doing. Does that make sense? Yeah? Okay, so this first fraction, can I factor anything? Nope. So we have r to the 5th over r plus 4. And then what am I going to do with the division? Make it multiplication. Okay, and then what are we going to do here? Good, we're going to flip it, right? And so, okay, so the part that's going to the top, we can take out a 2, and we're left with r plus 4, and then 2r squared goes to the denominator. Do you have any questions there?
Can we like rewrite it and then solve it?
Mm-hmm. Like what we just did?
I think I'm using the first one.
I'm confused. Are we good? Okay. All right, so now what?
Cancel out.
Good. R plus 4, so those are exactly the same. They can reduce. Anything else? Twos? Good. So 2 R's will cancel, and then how many will be left right here? And so what's my final answer? Good. Any questions? Okay. So last example. Do you guys prefer to, were you saying to rewrite it first and then go from there? So we'll rewrite it. This really means k plus 4 over k squared plus 5k plus 6 divided by 3k squared plus 12k over 2k squared plus 5k minus 3. Oops. So this one looks like there is quite a bit of factoring, but you guys are getting very good at it. So, oh, and did you mean to like rewrite this and put times and then flip it and then factor? Yes?
No, I meant what my question was, could we factor numbers like that before you?
Sure, as long as you make sure that you end up flipping it before you reduce.
Not factoring, I'm sorry, reducing.
Yeah, so you can't reduce until you have them in the correct, because you don't know what's on top and what's on bottom.
Mm-hmm.
Okay. So yeah, at this point, if you want to rewrite this as k plus 4 over k squared plus 5k plus 6 times, and then rewrite this 2k squared plus 5k minus 3 over 3k squared plus 12k. If you want to rewrite that before you factor, you can. If you don't want to, that's fine too. All right, so now we need a factor. Can I factor k plus 4? No, that one's done. Can I factor k squared plus 5k plus 6? Yes. Okay, good. So my multiplication is 6. My adding is 5. What numbers work? 2 and 3 is correct. How do I write it? K plus 2, k plus 3. Good. Times. Over here. So we have this problem right here. What do I have to do? Okay, so my multiplication number is, and my adding number is positive 5. And what numbers work? 6 and 1, negative 1 and 6. So when you add those together, it makes a positive 5. When we multiply them, it makes a negative 6. Now, can I use the shortcut on this? Okay, so to the side now, let's rewrite this out. We have 2k squared, and then what will I write? Plus 6k minus 1k or minus k, and then minus 3. So again, I'm just separating out the 5k to 6k and negative 1k, and we're keeping the 2k squared and the minus 3 the same. What do I do next? Good, group them, and we can take out a 2k, and we're left with, good, k plus 3. What will I take out of the second group? Negative 1, and I'm left with k plus 3. If you want to write the next line here, you can. I'm just going to write it here. So what will be my factored form? 2k minus 1 and k plus 3. Okay, what about the denominator? Good. We just have a GCF, 3k, and what am I left with? K plus 4. So now that everything's factored, we can only reduce things that are the same. And what do we see? K plus 3s, K plus 4s. Anything else? Okay, so on the top we have 2k minus 1. The denominator, how will I write that?
3k.
Yes, Nia. Okay, so that's my final answer. Say that one more time.
Plus minus 3, k plus 2.
This is k plus 2.
Oh, it looked like k minus 12 for a second. That's why, from my angle, it's not in there.
There we go. Any other questions?